Hey, this is Don from Padlock Technologies again with the hoodie on this time. Got new merch, got a new hoodie, so it's a new video with new merch. So we're going to talk about uh, Phantom RP. Now, if you don't know what Phantom RP is, this has to do with multicast, and this is a let's say RP redundancy technique. Now you have Anycast RP, you can do this as well, but this is another technique where you're going to have redundant RPs, but it's going to use longest match as the technique. And if you know anything about routing, longest match wins. So let's get to the blackboard here and let's talk about it real quick. And this was a question that was actually asked to me or sent to me through email. Questions at padlocktech.com. By the way, if you want to send me or email me a question because you don't want to be in the comments, you can go there and then ask me a question there. And then if I'm making a video on it, I'll reply and tell you I'm making a video. So let's get to the blackboard here. So what is Phantom RP? Hopefully I spelled that right. If it's wrong, I'm a network engineer, not a spelling wizard. So bear with me. So Phantom RP is going to use a technique where you're going to have, let's say, we'll do this design here because sometimes you see this really in like VXLAN or MPBGP, EVPN kind of design. So we're just going to do a cloth fabric here real quick to demonstrate this. So this is going to be your spines. These are going to be your leaves. And then we're going to do this. All right. Now, because VXLAN uses multicast so we can join certain groups, your MCAS groups, and then those MCAS groups, whoever is listening to those MCAS groups, traffic is going, they're going to join it. And then, traffic can go through those different groups, basically. And that's just a broad overview of VXLAN. If you want me to do a more in-depth VXLAN video, put it in the comments, let me know, and we'll go from there. So what we're going to do is you can do one or two things. You can use a static RP assignment to do this. So you can do static RP, or you can do BSR. I would not suggest you use auto RP for this. I would really stick to BSR or static RP. Now, the key difference here is you're going to do BIDR, which is bidirectional PIM. And when you do bidirectional PIM, there is no S comma G's here. So we're going to put an S, a X through this. So no star comma or S comma G's. There will be all star comma G's. So it's going to be all star comma G's. So this means if you know anything about multicast, and if you want me to do, I think I did a multicast video about this as well. The star comma G's means any source going to a group, a multicast group. A S comma G is a specific source sending traffic to a specific group. Now, the key difference here is when you do anything that's not BIDR, you can only move down the tree, right? So you can only move down, traffic can only move down the tree, it cannot move up the tree, right? When you use BIDR, your senders can be receivers and your receivers can be senders. So now it can move up and down the tree. That's why you would use BIDR PIM instead of, normal, just, static BSR, which is bootstrap router, or auto RP if you want to use a Cisco proprietary thing. So what Phantom RP is you're going to have two loopbacks on here. You're going to have a loopback here. Let's say loopback 1, and we're going to have loopback 1 on this spine as well, right? Now the difference here is if you use ISIS, this happens automatically. If you use OSPF, and let's say this is a Nexus platform, you got to use this command called IP OSPF advertise subnet. All right. Now, the reason you're going to do this because that secondary loopback is not going to be a /32. Again, this Phantom RP is going to use the longest match to form some redundancy here. So let's say loopback 1 here could be 192, 168. Let's say I'm going to say 253, 30. All right. And then on spine 2, you're going to have 192, 168, 1.252, slash, don't quote me on this, I believe it's 29. All right. So because you have the longest match, when you go to join the tree or when you go to do a PIM join, you're going to go over to spine 1. Let me make sure this is spine 1, spine 2, because of longest match. The RP address, though, is going to be an address that fits not only in the 252/29, but it also fits in the /30. And what do you think that IP address is? I'll give you a couple seconds. I wish I had the Jeopardy music, but I don't. So if you don't know the answer, what's going to be shared between these two is going to be .254. Right? So that's going to be the address that is going to be the RP announced in the multicast domain, right? Even though it's not technically configured on any of these spine switches, it's an address that's in between those two ranges. So it doesn't, this is why it's called Phantom RP, right? Because the Phantom part is this IP address doesn't technically exist in the network. But because of longest match, it's going to say, okay, well, you're a /30, and I know that address technically fits in a /30. You're a /29. I know that address exists in that range as well. So because of that, it's a legit address. So now on your leaf switches, you're going to point all the leaf switches. Let me use blue. Will point to this as their RP address, right? So now when you go to do a PIM join, PIM join is layer 3, IGMP join is 2. IGMP is layer 2, PIM is layer 3, right? And then you have your report that turns into a PIM join. All right. So anything up here, just if you want me to do multicast, just put it like that. Just know IGMP is layer 2, PIM is layer 3, right? Because IGMP is not a layer 3 protocol. It's strictly at layer 2. So what ends up happening is once I do the join for my multicast group, I'm going to look for longest match. All right. If I say I'm going to .254, well, I know /30 fits that .254. So all my join messages are going to go to this spine switch, even though this address doesn't really exist. It's not configured. Again, Phantom RP. Always remember, Phantom RP means it does not exist. We're just using longest match to manipulate like it exists. And then I'm going to send all my join messages that way. So let's say what happens if spine 1 goes down? Well, everything now transitions over to 2 because of the longest match again. So now /30 doesn't exist, but I have a /29. So because I have a /29, I can still send my joins over to spine 2 because it's fitting in that range of 252/29. .254 fits in that range, right? So now I'm just going to send my stuff over to spine 2. So this is that's basically Phantom RP in a nutshell. Normally you're going to see this in a VXLAN MPBGP EVPN design. This is normally when you're going to see this, but I've done this in non-fabric designs as well. You can do this with static you can do it statically. So you can assign it, remember, static, or you can use BSR for this. I haven't really done it with auto RP because I kind of try to stay away from auto RP because that's Cisco proprietary and nobody does that, or nobody outside of the Cisco world does auto RP. So you're pretty much stuck with these two. Now in the campus network, and if you want me to create a video on this, normally if you have two different domains and you want to have redundant RPs, you can do Anycast RP, or you can use MSDP, which is multicast source distribution protocol. We can do a video about that if you want. Let me know in the comments, but those are just ways of doing RP redundancy. Anycast RP, like I said, MSDP for some, redundancy there. And now you have this new technique our somewhat new technique called Phantom RP. So I hope this video was informative. Don't forget to share, like, comment, and subscribe, especially on my multicast videos, because multicast, if you don't know, it can be very confusing. But once you kind of strip it back to its basics, it makes sense, especially when you're talking about moving down the tree as a rule. So you have your income interface list versus your outbound interface list. You got all kind of stuff. But I see a lot of people, especially, some of the people that I kind of tutor on the back end when it comes to getting your CCIE and stuff, they always get tripped up on multicast because not that many people use multicast, right? Unless you are like a stock company, stock trading, and you want to have your stock stuff going up and down on the screens, or you're like doing video. You see this in like stadiums and stuff like that, where you have those big Tron machines or multiple screens going across the stadium. They're usually using multicast because they're broadcasting the same thing. And again, the network is actually doing the replications of the packet. It is not the server doing it, or that whatever's sending the packet to the network is not doing the multicast, right? Or not replicating the packets. It's the network that's replicating the packets, right? So multicast is one to many, right? Broadcast is, all, and then multicast is one to many, but in a certain group, right? Again, hopefully this is informative. This is time for Padlock Technologies. Keep sending those questions. Thank you, and have a nice day.